Hello guys, so today we'll be looking at the lesson of differentiation under calculus. Okay, so if you look at this first, you see a graph with a curve. So in this curve, the gradient varies from point to point. So if we take a specific point such as this, then the gradient of that point is equal to the gradient of the tangent going through that point. So it would be something like that. The tangent to that point. So the gradient of this tangent, the gradient of this gradient, it's the same as the gradient of this point. So those two gradients are the same. So we could draw millions of tangents to this curve at different places. We could draw one here like that, or we could draw one here like that, and a lot of tangents to that curve. So that's that, and we'll be talking about maximums, lot of minimums, and a further bit more deep into this lesson. So today we'll be learning the basics of differentiation. Okay, so now we'll be looking at some rules under differentiation. So first one which we're going to learn is y is equal to x to the power n. So y is equal to x to the power n. So under differentiation, the symbol you represent differentiation is going to be y by dx for an equation of y. So let's say y is equal to 3x. The way you represent the differentiated version of this function is dy by dx. And if the function is f of x, we show differentiation using f prime x. This is the symbol we use to represent differentiation, the differential. So now we'll be looking at this and then we'll see how we have to differentiate this. Okay, so dy by dx, this is going to be, when you differentiate x to the power n, it comes front and this reduces by 1. So it's going to be n x to the power n minus 1. The power reduces by 1. First n comes to the front and the power reduces by 1. So this is a general rule that will come in handy in future. So that's that. So the second rule you are going to learn is going to be y is equal to ax to the power n, and dy by dx is going to be an x to the power n minus 1. So we look at this. A is a constant, where A is a constant, so x to the power n, same thing. So n comes to the front and is multiplied with A, and this is power is going to reduce to n minus 1. So that's the second rule we are going to learn. So now let's look what happens to a constant when they undergo differentiation. So third one, y is equal to k, where k is a constant. K is a constant. So when y is equal to k, the differential is going to be dy dx is going to be, k is a constant such as, it could be a number such as 5, 3, 2, minus 1, or it could be 5. Any number, any constant which is not a variable. So dy by dx is equal to 0, since there is no x terms involved here. So these three rules are a bit general rules which you have to keep in mind. So now we learned 3 rules so far. So we'll look at the 4th rule. So all of you know what E is the natural number. So y is equal to e to the power x. Okay, so now we'll be looking at how we can differentiate this. So dy by dx is going to be, now e is a special sort of constant. So e to the power x, when you differentiate it, it's going to be the same. So this is the rule you have to keep in mind. E to the power x, when you differentiate it, it's going to be the same. So this is for e to the power x. And the 5th one you're going to learn is going to be e to the power ax. So when you differentiate this, the letter a comes to the front. Yeah. So dy by dx is going to be equal to a e to the power ax. See, note that this entire thing is repeated here, while the differentiated version is here, a e to the power ax. So that is the 5th rule. And we'll be moving on now. So we'll move on to a bit of trig. So now I'm teaching you all the theory, and further we'll be looking into some questions that includes all of these differentiated versions. So the sixth rule you're going to learn is going to be y equals sine x. So when you differentiate sine, it's very simple, and you have to keep this in mind. When you differentiate sine, you get cos. So dy by dx is going to be equal to cos x. Okay. So the seventh rule you're going to learn is going to be y equals cos x, and when you differentiate y equals cos x, dy by dx is going to be minus sine x. So you have to keep this in mind. When you differentiate sine x, you get cos x, whereas when you differentiate cos x, you get minus sine x. So those two are a bit, you could get those two a bit confused, but keep this in mind. When you differentiate sine, you get cos, and then when you differentiate cos, you get minus sine. Just study that, and then those are simple theories we have to keep in mind. Okay, so we'll move on into another theory. Y equals sine ax, where a is a constant. So dy by dx is going to be, now we'll learn that sine x differentiated version is cos x. So sine ax, the differential is going to be a comes to the front. Yeah. So it's going to be a cos, and ax is still there. So the ninth rule we're going to learn now is going to be y equals cos ax. The differentiated version of this is going to be minus a sine ax. So I suggest that you make a note of all of these and box this, since these are important rules, and this will come into axiom here. So moving on, the 10th rule, y equals k f of x, where k is a constant. So it could be, k could be equal to 5, 3, or any number. Okay, so dy by dx here is going to be equal to k multiplied by f prime x. F prime x is the differentiated version of fx. So fx differential is going to be f dash x, and k remains here. K is a constant. It has no effect on differentiating since there is a multiplication here. So this is it that we learned so far. So now we'll look into more further application of these. Alright, so now we'll be discussing these questions. So these are simple, and all the rules we learned so far will be applying here. So first question, y is equal to x to the power 6. So now previously you learned that x to the power n, when you differentiate it, it's going to be nx to the power n minus 1. So same application here. So when you differentiate this, 6 comes to the front and power reduces by 1. So this is going to be equal to 6x to the power 5. So that's really simple. So this is the general pair. So now we'll move on to the second question, which is y is equal to 3x to the power 4. So now this is the format of ax to the power n, and when we differentiate this, the same method follows. So dy by dx is going to be 3 multiplied by 4, 4 comes to the forward, and x power decreased by 1, which is going to be 12x to the power 3. Alright, so that's that. And now we'll be moving into the third question, which is y is equal to 6x to the power 5 plus 2x to the power 8 plus 4. So up to now you have differentiated these single terms. But what do you do when you get multiple terms, 3 terms like this? So it's really simple. You consider these as individual terms and differentiate them respectively. So dy by dx is going to be, first to differentiate this. So you bring 5 to the forward and reduce power by 1, which is going to be 30x to the power 4. Since the power reduces by 1, it's going to be power 4. When 5 comes forward, 5 multiplied by 6, which is going to be 30. So same procedure for this, which is plus. 8 into 2, which is going to be 16, x, and power decreases, 8 minus 1, which is going to be 7. Now plus 4 is a constant. We noted that when you differentiate a constant, it's going to be 0. So this is going to be plus 0. So this is the answer for that. So we looked at 3 questions now. Now we'll be moving into this question. So y is equal to x to the power half. Now a bit more tricky thing. So now I'll try this here. Same procedure as all before. So we're going to bring half to the forward, then x half minus 1. So this is going to be half x to the power minus half. So now it's x to the power negative. X has a negative power. So we bring it down and make it positive. So it's going to be half multiplied by 1 over x to the power half. Anything to the power half, that means basically square rooting. So when you simplify it and write, it's going to be 2 root x. Root x as same as x to the power half. So that's that, and we discussed this. So far we discussed all of this. Alright, so we'll move on to this. The next question, which is y is equal to x over x to the power 5. So now it's a fraction. So some of you, if you might know quotient rule, you might think that it's an application of that. But no, this is really simple, and if you know that, you can cancel out 1x. So which is going to be, we can write this as x to the power minus 4. If you cancel 1x from both, then it's going to be 1 over x to the power 4, which you can write as x to the power minus 4. So now when you differentiate that, its power comes to the forward and minus 4x, and here the power is subtracted. So it's going to be minus 4 minus 1, which is going to be minus 5. So you can write this as minus 4 divided by x to the power 5. And that's that. So we discussed all of this so far. Now we'll be moving on. Alright, so now we'll move on with the next question, which is cos x plus sin x. So it's going to be y equals cos x plus sin x. So when you differentiate this, now we learned in the previous rules that when you differentiate cos x, you're going to get minus sin x. And when you differentiate sin x, you're going to get cos x. So it's really simple. Differentiate them individually, one at a time. So when you differentiate cos x, it's minus sin of x. And when you differentiate sin x, you're going to end up with cos x. So that's that. That's it. That question also done. So we'll move on to the next one, which is y equals 3 minus cos x. So this is also simple, same format. So dy by dx is going to be, when you differentiate this constant, you're going to end up with 0. So 0 minus, now when you differentiate cos x, you're going to get minus sin x. But not that, there is another minus outside. So you should include brackets here to avoid confusion. So when you multiply two negative powers, you're going to end up with the positive power. So it's going to be sin of x. And that's that. So that's even done. So now we're moving into e to the power x formats. So y is equal to e to the power x minus x. Okay, so now we're going to deal with each at one at a time. So dy by dx is going to be, so e to the power x, when you differentiate e to the power x, you're going to end up with e to the power x. Since e to the power x is a bit stubborn and not willing to differentiate, so yeah. And when you differentiate x, you're going to end up with 1. But there is a negative sign, so it's going to be minus 1. So some of you might wonder why when you differentiate x, you're going to end up with 1. So I'll prove that. So y is equal to x. So once you differentiate this is, we can write this as x to the power 1. So 1 comes to the front and x, 1 minus 1. So this is going to be 1x to the power 0, which is going to be 1. Anything to the power 0 is 1, so 1 into 1 is equal to 1. Yeah. So that's that, and we're done with this. The next question is going to be y equals e to the power 3x plus 2. Now this is a bit of a different format. So I'll teach you how we can do this. So I'll give you the general format. So y is equal to e to the power ax plus b. When there is a question like this, you can differentiate this as dy by dx. You bring a to the front, so it's going to be a e to the power ax plus b. Rest is going to be same. So if you look at this, it's the same function repeated over here with the differentiated version of this part here, which is a. So a comes here too, yeah, and the same function is repeated. So that's it. So we're going to follow the same general format. So dy by dx, this is going to be 3 e to the power 3x plus 2. So that's it. Yeah. So that's also an easy sum. So now we'll move on to the last question. So this is going to be that, and once you differentiate this, so now we learned cos ax and sin ax, what happens when you differentiate them. So we'll do that. Dy by dx is going to be, when you differentiate cos ax, you're going to end up with minus a sin ax. So we're going to do that, and minus 5 multiplied by, so I'm going to take 2 out. The minus sign is from the cos turning into sine, so it's going to be sine 2x plus, now when there is 6 sine 4x, so sine ax, once you differentiate it, it's going to be a cos ax. So you take 4 out, which is going to be 6 multiplied by 4 cos 4x. So this you can write it as minus 10 sine 2x plus 24 cos 4x. And that's that. So that's basically it with the questions, and we're done so far. So all of these theories are pretty simple, and application is simple as well. So now this is the end of the lesson of differentiation part 1. So I hope you enjoyed this, and subscribe for more of these videos, and have a nice day. Thank you for watching this.